Envision a time eons past, ages before Earth, before planets, before even our sun. What existed then? A colossal cloud, vast, shadowy, and frigid. This cloud drifted through the cosmos, composed of gas and dust. Today, picture it as a celestial mist, but far grander than any fog on Earth. This cloud cradled all essentials, all to birth our solar system. This wondrous cloud is known as a solar nebula. Solar signifies its connection to the sun. Nebula, from Latin, means cloud. Thus, it was the sun's cloud. This nebula was truly immense, spanning light years across the void. A light year is the distance light journeys in a year, an unfathomably vast expanse. Within this vast cloud, particles were dispersed. They were scattered far and wide. The gas was predominantly hydrogen. Hydrogen, the simplest and lightest element, the most abundant substance in the universe. There was also helium, another light gas. The dust consisted of minuscule fragments, tiny shards of rock and ice, like the finest grains of smoke or sand. These grains were unimaginably small, smaller than the mind can fathom. Yet, there were trillions upon trillions of them. This immense cloud was not static. It was slowly, gracefully swirling. It was a frigid realm distant from any stars. The temperature hovered just above absolute zero. Absolute zero is the coldest conceivable temperature. Nothing can be colder than that. Thus this cloud was a very cold, dark and silent place. Yet it brimmed with potential. It was the cradle of our future abode, the dawn of our cosmic tale. So this huge cloud of gas and dust floated in space. What happened next to this giant nebula? Something started to pull it together. That something was gravity. Gravity is a force. It is the same force that pulls you down. It keeps your feet on the ground. It makes an apple fall from a tree. Gravity pulls everything with mass towards everything else. It is a fundamental force of the universe. This force of gravity began to act on the cloud. Every particle of gas and dust pulled on every other particle. Slowly, very slowly, the cloud started to shrink. It began to contract under its own weight. This process is called gravitational collapse. Imagine squeezing a soft ball of cotton. The cloud was like that, but gravity was doing the squeezing. This was a very important step. The first step towards making stars and planets. Perhaps something gave it a nudge, a little push to start the collapse. Maybe a shock wave from a nearby exploding star, a supernova, we call it. This shock wave could have compressed parts of the cloud, making them dense enough for gravity to take over. Or maybe it was just the gentle, patient pull of gravity itself, working over millions of years. We are still learning the exact details, but we know gravity played the main role. As the cloud squeezed together, it did not stay spread out. The particles came closer to each other. This made the cloud denser, especially in certain regions. Some parts of the cloud started to clump up. These clumps became the seeds of future stars. Our sun was born from one such clump. Gravity was the sculptor. It was shaping the raw material of the cosmos. It was beginning a magnificent creation. As this giant cloud of gas and dust collapsed, something else started to happen. It began to spin faster and faster. Why did it spin faster? Think of an ice skater. When a skater pulls their arms in, they spin faster. This is a rule in physics. It is called the conservation of angular momentum. The cloud was like that ice skater. As it got smaller, it spun more rapidly. This spinning had a very important effect. It stopped the cloud from collapsing into just one big ball. Instead, the cloud began to flatten. Imagine spinning a ball of pizza dough in the air. It spreads out and flattens into a disc shape. The same thing happened to our solar nebula. The material fell inward towards the center, but the spinning motion pushed it outward at the equator. This created a huge, flat, spinning disk. This spinning disk is called a protoplanetary disk. Proto means early or first. Planetary means it will form planets. So it was an early disk where planets would soon be born. The disk was densest at its center. This central part would become our sun. The rest of the disk was thinner. It stretched out for billions of miles. All the future planets, moons, and asteroids would form from this disk. The protoplanetary disk was not a calm place. It was a swirling vortex of gas and dust. Material was constantly moving around, spiraling inwards towards the growing center, or being thrown outwards by the spin. It was a dynamic and exciting environment, like a cosmic construction site. The raw materials were there. The spinning motion was organizing them. The stage was being set for the next act. Most of the material from the collapsing cloud did not stay in the outer disk. A huge amount of gas and dust spiraled inward. It collected at the very center of the spinning disk. This central region became denser and denser. As more material fell in, the pressure increased, and with more pressure came more heat. The center of the disk started to get very, very hot, hotter than anything you can imagine. This hot, dense core at the center was not yet a star. It was a protostar, a baby star still growing. It continued to gather more gas and dust. It grew bigger and hotter over thousands of years. The temperature at its core climbed higher and higher, reaching millions of degrees Celsius. The pressure became immense, unbelievably strong. Something incredible was about to happen deep inside. Then the magic moment arrived. The core of the protostar became so hot and dense, so incredibly squeezed, that a new process began. Hydrogen atoms started to smash together. They fused to form helium atoms. This process is called nuclear fusion. It releases a tremendous amount of energy. This energy pushed outwards, balancing the inward pull of gravity. A star was born. Our sun ignited. The birth of the sun was a dramatic event. It lit up the protoplanetary disk. It sent out light and heat in all directions. This young sun was now a stable star, shining brightly at the center of the solar system. It had taken millions of years. From a cold, dark cloud to a blazing star, the sun's energy would now shape the rest of the disk. It would power the formation of the planets. Our solar system finally had its star. Section 5, Cosmic Dust Bunnies, the first small steps. With the sun shining brightly at the center, what about the rest of the disk? The protoplanetary disk was still full of gas and dust. This material was orbiting the young sun. Think of it like a giant cosmic racetrack. Tiny particles of dust were zooming around. These dust grains were very small, like particles of smoke or fine sand. But there were countless numbers of them, floating in the gas. These tiny dust grains started to stick together, and how did they stick? Sometimes they just bumped into each other gently, and they clung together because of static electricity, like how a balloon sticks to a wall after you rub it. Or sometimes sticky coatings of ice helped them join. Very slowly, these dust grains formed slightly larger clumps, like tiny dust bunnies floating in space. This was the very beginning of planet formation. These small clumps were not very big, maybe only a few centimeters across, or perhaps the size of pebbles. But this was a crucial step. It was the first time individual grains came together to form something a little bit bigger. This process is called coagulation. It is like snowflakes forming from tiny ice crystals, or raindrops forming from tiny water droplets in a cloud. These cosmic dust bunnies were the seeds of future worlds. The regions closer to the new sun were hotter. Here, only rocky materials could survive. Materials like silicates and metals. These formed rocky dust bunnies. Further away from the sun, it was much colder, beyond a point called the frost line. Here, ices could also exist. Water ice, methane ice, ammonia ice. So, The dust bunnies in the outer disk were icier. This difference was very important for the types of planets that would form. Section 6. Building blocks emerge. The planetesimal era. The little dust bunnies did not stay small for long. They continued to sweep up more material. As they moved through the disk, they collided with other dust grains and with other small clumps. If the collision was gentle, they would stick together, growing larger and larger. Slowly, over thousands and millions of years, these clumps grew from pebble-sized objects to boulder-sized objects, and then even bigger. Eventually, these growing bodies reached sizes of a kilometer across, or even hundreds of kilometers. These larger objects are called planetesimals. Planetesimal means a small baby planet or a piece of a planet. They were the first true building blocks of planets. There were millions of these planetesimals orbiting the young sun, each one following its own path around the star like a swarm of cosmic bees. These planetesimals were made of different things, depending on where they formed in the disk. Near the sun, they were rocky and metallic, made of the same stuff that forms Earth and Mars. In the colder outer regions of the disk, beyond the frost line, the planetesimals were a mix of rock and ice, lots and lots of ice. This ice made them bigger and more massive. The era of planetesimals was a busy time. The disk was crowded with these new objects. They were constantly interacting with each other. Their gravity started to become important. They pulled on each other. Sometimes they would pass by closely, other times they would collide. These interactions were shaping their future. Some would grow, some would be shattered into smaller pieces. The solar system was a chaotic construction zone. Section 7. Worlds in the making. Planets take their shape. The planetesimals were the building blocks. Now it was time to build planets. How did this happen? Through more collisions and sticking together, the larger planetesimals had stronger gravity. Their gravity pulled in smaller planetesimals, and also dust and gas from the surrounding disk. This process is called accretion. It is like a snowball rolling down a hill. It gets bigger and bigger as it picks up more snow. When planetesimals collided, sometimes they stuck, forming an even larger body. If they were big enough, their gravity was strong enough to hold onto the material from the collision over millions of years. Some planetesimals grew much faster than others. They became the dominant bodies in their part of the disk, sweeping up most of the nearby material. These became protoplanets, almost planets. They were large, spherical bodies in the inner solar system, close to the sun. The protoplanets were made of rock and metal. They grew by colliding with rocky planetesimals. These became the terrestrial planets: Mercury, Venus, Earth, and Mars. They are relatively small and dense because there was less solid material available in the warmer inner disk, and the sun's solar wind blew away much of the gas. In the outer solar system, it was a different story. The protoplanets there grew much, much larger. They started as icy and rocky cores, similar to the inner planets but with more ice because they were beyond the frost line. These cores became very massive, so massive that their gravity was strong enough to pull in huge amounts of gas, hydrogen and helium gas from the surrounding disk. This formed the gas giants, Jupiter and Saturn, and the ice giants, Uranus and Neptune. As Section 8, beyond the planets, moons, asteroids, and comets. Not all the material in the protoplanetary disk ended up in planets. There was a lot of stuff left over. Many planetesimals never became part of a planet. These leftovers became other interesting objects that we still see in our solar system today. They tell us a lot about the early days. They are like cosmic fossils, preserving clues from that ancient time. Many of the rocky planetesimals in the inner solar system, especially those between Mars and Jupiter, they could not form a planet. Jupiter's strong gravity kept stirring them up, preventing them from clumping together. These became the asteroids. They form the asteroid belt, a region filled with millions of rocky bodies, ranging in size from tiny pebbles to dwarf planets like Ceres, which is nearly 1,000 kilometers across. Further out, in the cold depths of the solar system, beyond the orbit of Neptune, there were many icy planetesimals. These are the comets. They are like dirty snowballs, made of ice, dust, and rock. Most comets reside in two distant regions, the Kuiper belt, just beyond Neptune, and the even more distant Oort cloud, which surrounds the entire solar system. Sometimes a comet gets nudged and it travels towards the sun, developing a beautiful tail as it gets warmer. And what about moons? Planets also have companions called moons. Our Earth has one moon. Mars has 2 small moons. Jupiter and Saturn have dozens of them. Some moons may have formed from the disk of gas and dust, a disk that surrounded a young, growing planet, just like a mini solar system. Other moons might be captured planetesimals that strayed too close to a planet and got caught by its gravity. Our own moon likely formed from a giant impact, a huge collision with early Earth. Section 9, Our Solar System, A Journey Through Time. So there you have it, the incredible story of how our solar system was born. It all started with a vast, cold cloud, a cloud of gas and dust, the solar nebula. Gravity pulled this cloud together, making it shrink and spin. It flattened into a giant disk, and a protoplanetary disk is swirling around a growing center. That center became incredibly hot and dense until it burst into life as our sun, a brilliant new star. In the disk surrounding the young sun, tiny dust grains stuck together, forming larger clumps, then pebble-sized objects. These grew into kilometer-sized planetesimals, the building blocks of planets. Through countless collisions and mergers, these planetesimals grew into protoplanets, and finally, into the planets we know today. Rocky planets like Earth in the warm inner regions. Giant gas and ice planets in the cold outer regions. What an amazing construction project. The journey did not end there. Leftover planetesimals became asteroids and comets. Moons formed around the planets. Each object found its place, settling into stable orbits around the sun. The solar system became a more orderly place after the chaotic early years of formation. This whole process took hundreds of millions of years, a tiny fraction of the universe's age, but a very important time for us. This process of star and planet formation is not unique. We see similar disks around other young stars. We have discovered thousands of planets orbiting other stars. These are called exoplanets. It means our solar system is not alone. The universe is full of such wonders, but full of possibilities. Our cosmic home, the solar system, is a beautiful example of nature's creative power, a product of gravity, chance, and time, a place for us to explore and understand,